Hey guys, Mr. Ainsworth here, and we're going to get through review 1 together here on integration techniques. Covers lessons 1 through 4, A and B. So let's give these a shot together and check your work as you go. So number 49, if you look in your calc book here, looks like the integral of sine of 2x times the cosine of 2x dx. And this is not the sine of x or the cosine of x, so this is going to involve a u substitution. So the question for you is, are you going to let u equal to the angle 2x or the entire trig function? So let's explore and find out what works and what doesn't work. I'm going to let u equal to the angle first and see if that's a good choice. And if it's a good choice, we'll continue, and if it's a bad choice, we're going to step back and we're going to try something else and learn from our experience. So I'm going to differentiate here. I got du is equal to 2 dx. I need to find out what dx is, so I'm going to divide both sides by 2, so I get 1/2 du equals dx here. So this portion right here is 1/2 du, and everywhere I see a 2x, that's u. So when I rewrite in terms of u, I've got sine of u times cosine of u times 1/2 du. And that's going to be tough to integrate because I don't know of a function whose derivative is sine times cosine. So what that tells me is that this was a bad choice. Okay, bad choice of u. Okay, so we're going to learn from our experience and try something else. We're going to let u equal to the entire trig function. So instead we're going to let u equal to the sine of 2x and see what happens. Now you might be wondering, hey, why not cosine of 2x? And that's a good question. You should try that. In fact, we'll try that next and see what happens. Okay, you're going to find something unique out. So what's going to happen here? Well, we got du is equal to 2 cosine of 2x dx. Okay, that's using the chain rule. Okay, and then I'm going to, let me rewrite the integral down here. Sine of 2x times cosine of 2x here dx. So now my u is going to be equal to this entire trig function. I don't see a 1/2 in the integral or 2 in the integral, so I'm going to divide both sides by 2, and I get 1/2 du equals cosine of 2x dx. All right, so this right here is 1/2 du. So and then I want to rewrite the integral now, and rewrite it as an integral of u times 1/2 du. I'm going to pull that 1/2 out and write it as 1/2 times the integral of u to u. Okay, and that's easy to integrate. So this is a good choice. All right. So I know that my original u substitution, this is a good choice, as opposed to the other one, that was a bad choice. Because I can integrate 1/2 times the integral of u. That's easy. Okay, and what I get is 1/2 times u squared divided by 2 plus constant, and that's going to be equal to 1/4 now times u squared, but u is equal to, let's see, it's right here. U is equal to sine of 2x, so I want to square that. So what I get is the sine squared, okay, of 2x plus c. Okay, now let's compare that with the other possibility here. I said that you can let u equal to cosine of 2x and you'll get a similar result. So now let u equal to the cosine of 2x and see what happens. We're going to get du is equal to -2 times the sine of 2x here, dx. That's differentiating. The derivative of cosine is negative sine, and the times the derivative of the inside function, which is 2. I don't see a -2 in the integral. Actually, let me rewrite it down here so I can separate my work and my thinking here. Okay, so now what I have is that I have u equal to this entire function. I'm going to divide both sides by 2 here. So I get -1/2 to u is equal to sine of 2x dx. Okay, so this other portion right here, right there, the sine of 2x dx, that's my -1/2 to u. So when I rewrite in terms of u, I get the integral of u times -1/2 du. or negative 1/2 times the integral of u, whoops, not u squared, but just u, du. Okay, integrate, I get negative 1/2 times u squared divided by 2 plus c. And then I bring that in, simplify a little bit. I get negative 1/4 now times cosine squared of 2x plus c. Now let's compare our end results, this one and this one. Compare. They look different, but believe it or not, they are actually the same. And I'll show you. This right here is equal to 1 minus sine squared of 2x. Because I know, okay, that cosine squared of 2x plus sine squared of 2x is always equal to 1. And because of that, I can make a little substitution in. I can rewrite it as negative 1/4 times 1 minus sine squared of 2x, all right, plus c. And if I distribute through, I get negative 1/4 plus 1/4, sine squared of 2x here, plus c. And then if you compare these two, you're going to say, hey, they're not the same, they're different. And I disagree with you because I noticed that both involve the 1/4 sine squared of 2x, and I know that right here, a constant plus a constant is just another constant. So this is actually equal to 1/4 sine squared of 2x plus c, because a constant plus a constant is just another constant. Okay, so depending on your use substitution, you may get two different integrals or two different solutions, which may look different, but believe it or not, if you check them, they're actually the same. That's the beauty of calculus right there. Okay, so you're going to have to really practice and check your work on this one when integration is involved. Okay, you can always check your results by differentiation too. Remember that. All right, and that's number 49. Let's try number 50. Okay, number 50 is the integral of secant of 1 minus x times the tangent of 1 minus x dx. Okay, and anytime you have a where the angle is not x, if it's anything else, it's going to probably involve a u substitution. So right here, I'm going to let u equal to the angle and see what happens. Okay, and I differentiate, I get du is equal to going to be equal to negative dx, and I want to isolate dx, so I get negative du is equal to dx. That's this portion right here. That's a negative du. And I want to just go ahead and write it in terms of u. So I get the secant of u times the tangent of u times, okay, a negative du. Or you can bring that negative out in front and write it as negative the integral of secant of u times tangent u du. Okay. So what we get is we're looking for a function whose derivative is secant tangent, and it happens to be secant. So I'm going to get a negative secant of u plus c, and then I have to substitute x back in, so bring back 1 minus x in, and you get the end result. You can differentiate this and check it, and it should be equal to the original function here. Okay. Number 51 is the integral of tangent to the 4th x times secant squared x dx. Okay, and again, this is practice on u substitution techniques, and what you want to do is you want to pick a u so that it's du, the derivative, is somewhere else in the integral. And I know that the derivative of tangent is secant squared, so picking u equal to tangent x would be a good choice here, because the u equals secant squared x dx. All right, and so this portion right here is simply du, and right here I'm going to have u to the 4th. So when I rewrite this, it's very simple. I just get u to the 4th du when I rewrite it, and that's u to the 5th divided by 5 plus c. And then you write it as 1/5 times the tangent to the 5th x plus c when you bring back tangent in. Okay, so pretty simple, but you know, it takes the experience. So you got to do your homework, and you got to do a lot of these to get it down. Number 52.
We need the following.
Okay, so the integral of the square root of tangent x times secant squared x dx. Once again, you want to pick a function for u whose derivative is somewhere else in the integral. And we know the derivative of tangent is secant squared, so my first thought would be letting u equal to tangent x here, or u right here. Because I know that the derivative is secant squared x dx. So this portion is nothing more than du. So when I rewrite the integral, I get the integral of the root u du. It's pretty simple. But I also know that that's u to the 1/2 power du, and that's going to be u to the 1/2 plus 1 divided by 1/2 plus 1 plus c, and that's going to be u to the 3/2, all right, divided by 3/2 or multiplied by 2/3. And then bring back u, so you get 2/3 times tangent cubed, or the square root of tangent cubed x plus c. Or you can just raise it to the 3/2 power too as well. But you know, the denominator is the root and the numerator is the power. Okay, number 53. Here we have the integral of cosecant squared x, all right, divided by cotangent cubed x dx. And I want to pick the function here, let u equal to a function whose derivative is somewhere else in the integral. And I know the derivative of cotangent is cosecant squared, so my first thought would be to let u equal to cotangent x, because I know that du is equal to negative cosecant squared x dx. And all I have to do is just shift over that negative sign. I can say that negative du is equal to cosecant squared x dx. So this numerator right here is going to be your negative du. And let me see, so right here, let me see, this is going to be my u cubed in the denominator, and then in the numerator it's going to be negative du. So when you rewrite this one, it's going to be negative du, the integral of negative du, all divided by u cubed. And that's simply negative the integral of u to the negative 3 du. Rewrite exponentially all the time. And then you get negative u to the negative 2 divided by negative 2 plus c. When you use your power rule, add 1 to the exponent, divide by that value. And that's going to be 1 over u squared plus c. And then bring back cotangent in. So you get 1 divided by the cotangent squared x, because you've got to square the function, plus some constant. Okay, number 54. Is the integral of sine x divided by cosine cubed x dx. And I'm going to let the function being raised to the power be u. You want to let u equal to the inside function. So don't choose u equal to sine x. That'd be a bad choice. So let u equal to cosine x, because we know that du is equal to negative sine x dx here. And adjust the negative, just say negative du is equal to sine x, sine x dx here. So this portion right here is just negative du. And then of course I'm going to have a u cubed in the denominator. So when I rewrite this integral, it's going to be the integral of negative du divided by u cubed. Once again, you just rewrite it as negative the integral of u to negative 3 du, and then integrate negative u to the negative 2 divided by negative 2 plus c, just like in the last one. Because you're going to add 1 to negative 3, which is negative 2, divide by that value, and you get 1 over u squared plus c, which is 1 over cosine squared x plus c, which you can write as just secant squared x plus c. Okay, number 55 is the integral of cotangent x squared x dx. And on this one here, what I suggest you do, let's see here. Well, this is a challenging one. Let's see, what would be the easiest way? Gonna probably have to use a trig identity here. Okay, so we know that 1 plus cotangent squared x equals cosecant squared x previously. So if I isolate cotangent squared x, I get cosecant squared x minus 1. So what I want to do is rewrite the integral as the integral of cosecant squared x minus 1 dx and integrate both of those separately. So I want to integrate, let me write it over here, I have more room, got to write it down correctly here. Okay, integral of cosecant squared x dx minus the integral 1 dx. I'm looking for a function here whose derivative is cosecant squared, and that's negative cotangent squared. So I get negative cotangent x plus c, but that the constants are going to be combined. And then here, minus x plus some constant. So the trick on this one is use a trig identity, do a substitution, all right, and then integrate each one separately. Okay? And then, of course, just differentiate that, and you can check your results. Okay, there's number 56 is the integral of cosecant squared of x divided by 2. Ooh, it's not x now, so it's going to involve a u substitution here. So let u equal to the angle here of x divided by 2, so that du is equal to 1/2 dx, or t du, 2 du equals dx. So this portion right here is just 2 du. And so when you rewrite this one, you get the integral, of cosecant squared u times 2 du. Bring that 2 out. All right, so 2 times the integral of cosecant squared u du, and that's going to be 2 times. Now this right here is going to be negative cotangent as previously, u plus c, because the derivative of negative cotangent is positive cosecant squared u. Bring back u in, so I get negative 2 times the cotangent of not u, but, well, x divided by 2. And then 2 times c is just another constant, so c again. All right, and there's number 56. Number 57, we want to find an equation, so find f here. Find the original f of x. Okay, given f prime is equal to cosine of x divided by 2, and it runs through, okay, the point 0.03. Okay, that's your initial condition. Okay, so we got to solve this differential equation, so we want to integrate both sides. Okay, so let's do that. Let's take the integral of f prime in respect to x, and let's integrate cosine of x divided by 2 dx. The integral of f prime would be f, and here, again, this involves a u substitution here. Anytime a function, when you integrate it, when it does not involve just x, you have to do a u substitution, basically. So we're going to let u equal to x divided by 2, so that du is equal to 1/2 dx. And that means that 2 times du equals dx. So I'm going to rewrite this integral as the integral of cosine of u times, all right, 2 du. And you can bring out that 2 if you want, and write it as 2 times the integral of cosine of u du. Okay? This is a video, so you can always pause me and slow me down. The integral of cosine is sine because the derivative of sine is cosine. So this is 2 times the integral of u plus c. And then, of course, I got to bring back x in. So we know that u is equal to 1/2 x. And so I get 2 times the sine of x divided by 2 plus some c. And that's equal to my function. This is the general solution. All right, but I want the specific one. I want it through 0, 3. So x is 0, and your f of 0 is 3. So I want to substitute in 3 here, and then set that equal to 2 times the sine of 0 divided by 2 plus c. So 3 is equal to 2 times 0 plus c. So 3 equals c. And so that tells me that my constant of integration is 3. So my solution is f of x is equal to 2 times the sine of x divided by 2 plus, oops, not c, but 3. And there's my solution. Okay, so you're going to have to do that in numbers 58 through 62. All right, and so let me, I'm going to have you guys do the rest. So that's a good start on your homework right there. Go ahead and use this video for your resources or to help you out, and practice like crazy. The only way you get good at this U substitution and solving differential equations and all this integration is simply by practice, pure practice, a lot of it. All right, anything else? Talk to me in class. I'll see you then.